Okay, so hello everyone, and thank you for being here. Today's presentation falls under the umbrella of future environment. I'm going to take you on just a unique journey trying to convince you of making the impossible possible. So I will shed light on ongoing research that deals with gravity-defined architecture, also known as airborne architecture. I would like to start with a quote about the power of inventing the future rather than predicting it. I see a big deal of its truthfulness just by observing some of the current inventions that became a part of our daily lives. The talk is organized in three main parts. The first one deals with the impact of imagination on current and plausible future ideas and realizations. The second part talks about plausible future environments. The final section is about the case of GDA. Some of the materials used in this presentation falls under a fair use of others' work to illustrate a specific point for research, scholarship, and educational purposes. The power of imagination can sometimes modify or even recast the outcome of reality. The beauty of the two worlds, the one in the mind and the one in the physical realm, is that they are in a yin-yang relationship and are in a perpetual cycle, interacting with each other and ever-changing to produce different outcomes. One of the best examples is a powerful painting in a sense of how it portrays emptiness as a source of potentiality, mystery, and plausible scenarios that lies within our imagination. I can think of here these images that you see on the left that are taken from a sci-fi series which illustrate a city in 300 years from now, while the images on the right are actual images of current state of contemporary cities. In this one, it is Dubai, but of course, it's not the only city. Another correlation that I find to be remarkable is a movie shot of a digital projection of a screen on a building taken from Blade Runner, and the shot at Shibuya Crossing in Tokyo, Japan, one in 1982 and the other in 2017. Also, some designs that at a certain period were difficult to be constructed, while others were accomplished and built even though it seemed impossible to do so. And this remarkable project is the materialization by excellence of what a century can realize for a design that seemed unlikely and very challenging to construct. One has to admit that imagination, as subtle as it is a powerful tool that can mold the physicality of the future. On a pendulum that oscillates between an utopian or dystopian future cities, technologies in general will help create a multi-directional outcome of plausible futures rather than one singular and a uniquely directional one. Technology is a moving target, and with every advancement, there is an impact on society and, of course, on our environments. The three scenarios portrayed here are not the only one and can be stepping stone to even different environments. Here examples I'm showing AI, AR, and VR, these three technologies and the plausible impact on our future cities. Utopia towards cities of artificial intelligence. Kai-Fu Lee elaborates well when he mentions the four waves of AI, internet AI, business AI, perception AI, and finally, autonomous city. Towards cities of digital and sense-illusory environments, holotopia is when our physical reality is augmented by 3D assets that are mapped onto a 3D physical world. This is what philosopher Jean Baudrillard talks about hyper-reality, where people will not be able to differentiate between the real world and the digital photorealistic one. Then there is the Vitopia, towards city of dreams, imagination, and fantasies, the immersive virtual world, that goes back to Neil Stephenson and his renowned book, Snow Crash, that mentioned the term metaverse that everybody now is aware of. Now, of course, I'm going to take you on a bit different story with regards to the state of our planet. No matter how advanced humans think they are, nature will always be the mother of all inventions and inspiration. It is the most omnipresent, omnipotent, and omniscient teacher, and everything we discover has already been there in that same nature. Accordingly, we have to admit that there are things we do not yet comprehend very well. However, there is one important change that is backed by empirical data, which the human are a catalyst of, or even some would argue or debate that is the reason of, and that is climate change, which poses two behavior: mitigation and adaptation. In his book, Future Cities, Paul Dobravchik explains it perfectly when he mentions the flood scenario and the rising of the sea level caused by the melting ice in the polar region, which will create an apocalyptic dystopian type of future events. Of course, the flood idea is not new and goes back in history, whether from stories, myths, or legends. They are quite vivid in our collective memory. Specifically in his Unmoored Cities, the author talks about adaptation rather than just mitigation, and how cities might acclimate to the threat posed by climate change. He mentioned three ways: the drowned, the floating, and the airborne. Therefore, we easily identify the important relation between these scenarios and the work that I'm showcasing today, specifically the airborne scenario. So will architecture rise above it all? This is a challenging question to answer, but definitely is not a new one. And although an airborne structure may seem to some an impossible and unrealistic aspiration, others has argued that, and many individuals have tackled it directly or indirectly. Accordingly, one concurs that if you can levitate a train that weighed 50 tons, why not a house? Throughout human history, celestial bodies appearing in the skies, mysterious and weightless, have been always a source of adoration, admiration, aspiration, inspiration, and wonder. Of course, science explained and tried to demystify this, but it did not deter many from keep wondering about it. We all know gravity with a capital G, and we say the law of gravity because we all have to abide by it. However, throughout human history, we always wanted to defy it in a way or another. One cannot talk about the human aspirations to levitate and fly without mentioning Abbas ibn Firnas, who was one of the main contributors to this field, to the degree that he is known to be the first aviator. Of course, many more have contributed, and many will still become part of this ongoing search on how we can defy gravity and conquer the skies. In our era, when someone mentions levitation or anti-gravity, the first thing that comes to one's mind are H.G. Wells' Cavorite or James Blish's Spin Dizzy. Both novels, First Man in the Moon and Cities in Flight, are indeed inspirational. Other examples like the 1726 Laputa Flying Island, the 1820 Minerva balloon, and Cloud 9 are but few. And since Notre Dame Cathedral of le XXe siècle in 1883 up until the Airlander of 2016, one can clearly see the blurry lines that has been smudged further between the imagined and the realized, and what seems to be an unfathomable idea in a TV sci-fi series might end up becoming a reality. Other artists, such as Thomas Saraceno in his famous installation Cloud Cities, and other works where he created accessible spheres and domes suspended in mid-air, have provided a true experience of what an aerial spaces can be and feel like. Also, floating furnitures and objects have been designed and executed. Another influential research is A.R.X. Pax, talking about magnetic field architecture. Others, such as Japanese Daishin system and the superconducting magnetic levitation technology, are pushing the envelope in that direction. All these engineers, artists, authors, and companies are attempting to defy gravity, where each of them has their vision and goals. Some are more practical, others are more symbolic or theoretical. No, now, where architects stand on that? Did they directly or indirectly try to do similar attempts? It would be an oversight to not start by mentioning Lebbeus Woods, who was considered one of the most revolutionary experimental and theoretical architects in our modern era. His geomagnetic flying machines are but a visual materialization of his interest in what the world would be like if we were free of conventional limits. Here we can clearly observe in many of the landmarks that there is the spirit of structurally challenged gravity, whether through creating a box in the air on small pillars such as Villa Savoy, or on few big posts such as Edo Tokyo Museum or Tokyo Big Sight. Even the attempt of creating a long cantilever in the case of K Museum is but a testament of that attempt. On the left is the Cantilever Gallery by Richard Rogers. This project cantilevered 27 meters out above the hillside. And on the right is the One Zabil, the link in between two towers, is a bridge with the longest cantilever in the world, according to the developer Ithra Dubai. Another powerful statement is by Santiago Calatrava in his Museum of Tomorrow masterpiece, where we can see a large overhanging of 75 meters in length. Here, a different nuance done by Kazuyo Sejima in her attempt to slender the structural pillars as if they barely exist, and the roof can be seen hovering, especially in her Serpentine Gallery on the right. Finally, one of the most interesting new attempts would be of Norman Foster's by generating an architectural roof that appears like it is floating on its own, of course, by eliminating all pillars. Here, the lightweight roof seems floating in the air like a flying saucer. Some of the selected work here have shown buildings that give the illusion of floating structures, but for obvious reasons, they all were connected to the ground in a way or another. Of course, architects' attempts are commendable on many levels, but the next obvious challenge would be to ask, will architecture be able to completely and independently liberate itself from the ground? And if it did, so will it lose its identity? Of course, as per Mandela's saying that it always seems impossible until it is done, and no matter what, technologies may evolve or become redundant, but the dream of flight will always be there. This leads to the current work of airborne architecture. Originally, the work initiated at the University of Tokyo. When I was doing my doctoral studies in Japan, I was experimenting on spaces of well-being and researching the impact of architecture on feeling and emotions. When I moved to Dubai, I decided to take this research further and add a breakthrough available technologies in order to allow architecture to levitate. The purpose was obvious: to totally create a secluded place separated from the city, within the city, thus the levitating structure. It was apparent to me that throughout its evolution, architecture has crawled out of caves, settled on grounds, surfaced on water, climbed on pilotis, stood tall, and even danced. Now it is about time to challenge itself, defy gravity, and rise up. So, what would be the benefit of doing so? Some are theoretical, symbolic, and even practical. Here are some, but not limited to the following. Create the first and only iconic architecture in the world that completely separates itself from the ground. Liberate the ground from building to generate more greenery and public spaces. Protect architecture from natural disasters such as floods and earthquakes. Set up the platform of a futuristic and innovative architecture that will allow for a new human experience among the skies. Accomplish that was perceived as impossible in places that knows no limits. With all the challenges and opportunities in this research thus far, I have used many methods in order to develop this work, and some will still be required to progress further, from generating evidence-based experiments to the interdisciplinary fields, finding the adequate support, logistically and financially, until the execution of prototypes, the scalability of them, and finally the mean of disseminating the result and outcome. In general, advancement in any field of study is an ongoing, ever-evolving, and an iterative process exercise. GDA research is not an exception, and although defy gravity, it still abides by the law of time. The main challenge of this research is to generate a totally self-sufficient, independent architecture that liberates itself from the ground and can stay well balanced in the air. Mainly technology, or lack of it, was one of the main factors that did not allow the application of such ideas. One of the results of the research has shown that some of the main components for the success and stability of the outcome are threefold: design, technology, and materiality. Of course, they're not the only ones, but they are the ones that I'm focusing on. Design, form, function, and structure are crucial to create a self-sufficient architecture with the right aesthetics, composition, and balance in order for it to float and functions in the air. Size, the scale of the project, will determine the type of architecture that could be considered for the work. This affects directly the weight of the structure that can reach in relation to the strengths of available technology. When I started generating prototypes, it was in a miniature dimension, almost 10 centimeters long and weighted 20 grams. Then with time, I managed to augment the size, scale, and model of the prototypes. The latest exhibition prototype is almost 2 meters long and weighted 2,000 grams. The next one currently in process will be of bigger size and scale, and perhaps also including different technologies. So this is talking about the technologies. There are many available and under consideration technologies, to state few: electromagnetic field, superconductivity, and unmanned aerial vehicle. Of course, materiality as well, and the search for the adequate material that can be light enough and at the same time rigid to withhold natural and human pressure. This affects directly the appearance, the weight of the project. So the dissemination of the work took different forms, but the focus was one. And one of the outcomes that took the attention of the public was Rising Oasis series of prototypes: the spring, the river, and the waterfall. These series are prototypes that came out of the ongoing research. The aspiration was to not stop at the idea, but to move forward and generate actual prototypes. The exhibition of the spring prototype was in the context of the Venice Biennale 2018. The exhibition of the river prototype was in Dubai, at Dubai Design Week in 2019, and the work was acknowledged by major media outlets such as the CNN. Then, when the pandemic hits, it was challenging to do a physical exhibition with the real physical prototypes. Therefore, I reverted to a different type of exhibitions here in the animation of the third prototype. Before I elaborate, of course, on the method, it was done in a virtual world, in a virtual city called Illuser. Some other exhibitions were plausible in pre-COVID time in Dubai and in Salerno. AIRBORNE, the waterfall prototype, also used virtual reality where people can one-to-one visit the space. Here are some examples of the exhibitions. Also, the video you can watch later if you want. I'll have my barcode and you can get all the contacts and the video out there. Here are, of course, some examples of the prototypes up close of both videos. So the research and exhibition were disseminated in many media outlets in the form of published articles, conference, and televised interviews. The most enjoyable experience was to see how people interacted with the project and the intriguing and sometimes the difficult questions they'd asked me about. Thank you, everyone, for your attentiveness. And please, if you want to know more about what I do, feel free to scan the barcode, and you'll get all the things that I do, including what I actually showcased. Thank you.